Alright, so this is just a quick operation of the circuit that I designed for my final project for analog. I don't know if you can see this very well, but that motor is turning right now. It's fairly light in this room, and the phototransistor is letting enough current through to operate this motor at about 90 RPMs, 3 volts. So now, however, if I take this off, if you can notice, the motor slows way down to almost nothing. So that's a quick demonstration of how this circuit works. Thank you. Okay, so this is the circuit right here. Now what we have here is a 3-volt source running through our branches here. Now this is a phototransistor. Now what a phototransistor does is it actually varies the current that's allowed through here. And then you can adjust it somewhat with your 10K potentiometer. But that current varies in this branch and heads down to our 2 transistors here. Now these 2 transistors are in a common configuration, which is called a Darlington pair, which it actually overall works like a regular transistor, but you get a multiple of the gains. See, you get the gain from this one and the gain from this one, and the gain of the overall system is equal to the product of those 2 individual gains of these 2N3904 transistors. Now, our DC motor here runs at 120 milliamps at 3 volts. Now, in full light conditions, this circuit will actually run that motor at 90 RPM, which is how fast it spins at that voltage. But what it does here is this varies the current, which controls this gate here and allows so much current through the collectors of these 2 transistors. So what you're doing is when there's more light, there's more current flowing through this branch, which opens these transistor switches and allows more current to flow. However, when you have a dark current, then it doesn't allow much current through here, and it closes these switches and doesn't allow the motor. It allows the motor to either turn more slowly or not at all, depending on how dark or light it is. Now this right here, you need this. This is called a flyback diode. Now see, since this motor is nothing more than a big inductor, when you switch this off, or if direction is ever reversed, an inductor resists changes in current. So in order to compensate for that change, you'll get a voltage spike. This motor will actually act like a voltage source. What this flyback diode allows you to do is the current only goes through the motor when it's in regular operation and the motor is spinning. However, when the motor stops, it acts like a voltage source, and it allows a return path back to that source so that you don't get a voltage spike through your transistors and wreck the rest of the circuit. So what you do is you would mount this on a line following robot, and you would have an LED mounted right next to your phototransistor, and you would draw a dark black line on paper. Now what that would do is your LED would reflect more light off of the white of the paper than the dark solid black. So in that way it would vary the current depending on what light was reflected, and it would work just in the way that I just explained. So thank you very much. This has been my final project for analog at UW-Platteville, and thank you for watching.